you already know them. So the last couple of days we've been working on this. You just haven't known it. We've been doing the math and the calculations, but we need to formalize it because this is the big theorem in calculus. Okay. They'll specifically ask you questions around this on the AP exam to see if you understand it. Okay. Not only will we ask you to calculate integrals, right, and antiderivatives and derivatives, but we will ask you specific theorem-based questions, right? So, let's.
Shut your mouth.
Yeah, that's a good idea. Plug your nose too.
Wow, that's on YouTube.
What are we talking about? All right, so we've been working with these types of problems, right? Integrals? Yeah. Let's say reason number 5 million, I will never be president. I will shut my mouth when I should. What's the antiderivative of x squared?
X cubed over 3 thirds.
Thank you, boys. And then we evaluate from 1 to 4, right?
Yes.
Okay, so 4 cubed over 3 minus 1 cubed over 3, right?
Yep.
Okay.
Yep.
Okay, we could finish that, right?
Yeah.
Okay, good. What we do with the fundamental theorem of calculus is we generalize that statement. We put f of x and f prime of x in there instead of an actual function. So this is the theorem that relates derivatives and antiderivatives.
Okay.
Okay, it puts everything together in a nice clean package. And the way it's stated, I'll show you. We'll state it formally, but you have a function, right? You analyze the antiderivative from 4 to 1. This is basically the statement the theorem makes. Okay, and again, you've been doing the work, right? Okay. So yeah, when we make this theorem statement, we won't put this in it, the antiderivative. Okay. So this is basically what it's going to look like. Right? So part of it is part of navigating the fundamental theorem of calculus is navigating the function notation. Okay, and if we call that f of x, it's right here, correct?
Yep.
Okay. We can write one way that we can state this theorem. We can call the antiderivative capital f of x. Like you call a derivative f prime, correct? Mm-hmm. Well, we can call an antiderivative capital f of x. And I can rewrite this now with my function notation. equals now this is the antiderivative evaluated, right? So we would write big F at 4 minus big F at 1. Right? Yeah. Good with that?
Yeah.
Now I can also, so I've now generalized the functions.
That's called generalizing.
Yeah, we're pretty close. One of the big things about math is that you will have items that work in specific instances, but in order to make it effective across mathematics as a whole, you have to generalize it and prove that it will work for mathematics as a whole, right?
Oh, yeah, we talked about
So part of this is generalizing the statement so we can prove that it works.
Yeah, we did something like this last year.
And then can I put like an A and a B here for the numbers?
Yeah.
Yeah.
I can. And then I can make that an official now that statement is generalized. Okay. And all we need to do to that statement to make it the fundamental theorem of calculus is attach the conditions to it. Assume that the function is, what's one of the big things for the year? Bingo. There you go. Okay. So, but you see how we've been working it already. You just have to generalize it. Okay. Another way that we can save this, okay, f of x is, big F of x is the antiderivative of f, correct? Could I say this?
Sure.
Yeah, because if I derive the antiderivative, they cancel each other out, right? You end up with the original function. So this is the AP preferred way to write it. This is how our book writes it. You need to be able to operate in both. Okay, so I would star this and just put an AP note. Because they like that because it's more simple, I think, honestly. It takes less ink. And if you think about it, when you print 200,000 calculus tests, you save that touch of ink, you're saving actually quite a bit of money, right?
Yeah.
With manufacturing logic. But also it is a more simple statement. Okay, so either of those will work.
Are you saying the question is going to ask us and it might look like that? Or do we have to write that down?
No, the question will contain it. I'll show you some. Yeah. So right now we're just building up to the theorem. Okay, here's the fundamental theorem of calculus. This is part 1, and we'll have a part 2 later. But this is officially the main one. Okay. We'll call it the FTC. So you don't have to write fun in capital letters all the time in math class. I'm sure that makes you suffer.
I don't
Okay.
write in the
So we need to assume that a function f of x is continuous on a closed interval from A to B. If capital F of x is an antiderivative of f of x on the interval needed. And then we make the statement that we've already talked about. Again, we can state this like this if we need to. So there's the fundamental thing of calculus. Okay, we have to have a continuous function to be able to analyze the integral. Okay. Questions? Go ahead.
So remember
Just the man of funny sounds today.
remember when we found initial conditions on C? This one?
Yeah.
Why would we use that here and not here? What is that in context?
Yeah, so with this theorem, we have an interval that's defined. We don't have any constants that are floating around that are nebulous. Right? Everything is very defined and works out very clean. But if you start with a problem where you're given a velocity, okay, you have to know the position of the car where it starts, an initial position, in order to calculate the antiderivative to get the position function. Does that make sense? It's very similar to what we're doing here, it's just a different method of calculating a function. Here we're calculating the area under the curve. In that instance, you would be trying to generate a function for position, which is a slight difference. Right. Okay, I think that's better. Okay, so a lot of the problems in your book, the examples are calculating integrals. Okay. So do you want me to show you a couple of funky ones?
Yeah.
Because you're going to probably run into some of them. Let's talk about again, I'll try to present you with the many ways this question could be asked. Okay, find the area under g of x equals x to the negative 3/4 plus 3x to the 5/3 over 1/3. So we'll rewrite it in the notation we've been using, right? We'll go from 1/3, and then x to the negative 3/4 plus 3x to the 5/3 dx. So again, we could have also just asked calculate this value, right? Those are the same question. All right, so what is the antiderivative of this statement?
X to the 1/4.
Yeah, add 1, right? X to the 1/4. Over 1, okay. Plus
X to the 8/3.
3x to 8/3 over 8/3 evaluated from this is fractions. Things can almost always be worse. Where do you come up with this stuff? Okay, we can rewrite these. So if you don't want to make this real messy with fractions on bottom, you can invert and multiply, right? So 4x to the 1/4 and 9x to the 8/3 over 8. You can clean that up a little bit. Let's take a trip back to math 2.
We might need to.
Copy dot flip. 1 times 4 over 1. 3 times 3 over 8.
I think it says 8/3.
Yeah, but you gotta flip it.
I know, what's that blob next to 9x? 9x to the
I don't know
what
what we're
thirds?
talking about.
9x to the what thirds? It's just a blob, you can't tell the number.
It's not just a blob. There's a number there, you just can't see it.
What number is it?
Okay, moving on. What number do you think it is?
I think it's 8.
Okay, that's there you go.
It looks like
So now evaluate. Do you remember what exponents mean?
Yes, it's 1/4.
I just put a triangle and said Illuminati for you.
Illuminati? That doesn't work in here.
Why not?
Because it doesn't work anywhere. Thanks, Jay-Z. Okay. Good.
This is not sure. Why?
Because you laugh.
This shirt is aging. Buttons missing. Tear. Okay, that's going to be a calculator problem. We won't bother with it by hand. Do you remember what I do want to make sure you know is, do you remember what these exponents mean? The bottom is the root. So that's a 4th root of 3 to the 1st power. That's a 4. Okay, I'll give you that one. But not the bottom. Okay. This is the cube root of 3 to the 8th. Now, could you calculate 3 to the 8th by hand?
Yeah.
The roots are always the hard part. So, if you run into those, it's usually like 4 to the 3/2. Right. So, if you run into these by hand, the square root obviously is 4 cubed. So, what's the square root of 4? 2. 2 cubed is 8. They're very manageable if they need to be. Okay. These, yeah, that's it. Okay. Moving on. I showed this to you last week. Does anybody remember what the antiderivative of 1 over x is?
With the
Natural
absolute.
You have to. Indefinite, right? So you'd add a plus c. Okay. So that is officially in this section It wasn't official last week, but now it is. Do you know why we put absolute value x on that?
Because we can't have a negative.
Yeah, natural log, look at the graph, is not defined in the negatives. The neat thing is, even if we have negative integral limits, we can still calculate the area under this curve using natural log. Okay. It is pretty cool, actually. So, because 1 over x has a domain in the negatives, right?
Yeah.
We can still analyze this function for the area under the curve. Because 1 over x looks like this, right? So we have negative values in 1 over x. We're going to use natural log to calculate the area there. So we're basically calculating this area. Okay, so natural log, absolute value x, evaluated from?
So how do you, if it doesn't have negative values, how do you evaluate a negative?
Answer will come out negative. What's the natural log of 1? Standard knowledge necessary is 0.
Say it louder next time.
Minus the natural log at 3, right? So the answer is the negative natural log of 3. Negative number, right?
Yeah.
How about that? Still works. Most of the time, that would be your standard answer on multiple choice exam. You don't need a calculator to do that. I will show you some more AP-focused problems tomorrow, like theorem problems, right? But for today, you know, the intro, you're just still calculating the same thing we've been doing. Right? So not a whole lot added mathematically for calculations. Any questions? No? Okay. Prelims. Okay, so again, tomorrow we'll show you some problems off AP exams. Some of them will be theorem focused. And then this is due Tuesday. Because I know a lot of you have basketball games tonight, right?
And tomorrow night.
And tomorrow, so. And it's stuff you've already been doing, so. If you're struggling with these, yeah, please, I can help you.